Alright, this is going to be the video for definite integrals. So for this first one, they give us f prime of x, and then they want us to figure out what f of 7 is, and they tell us we know that f of 3 equals 6. So you have to set up your definite integral, and your two limits are going to be the numbers that they gave you. So you put them in order. 3 is smaller, so it goes on the bottom. 7 is bigger, so it goes on top. And then we can put 5x plus 1 here, dx. And then based on the first fundamental theorem of calculus, we know this is going to equal f of 7 minus f of 1. Not 1, 3. So then we just have to solve this definite integral. So you can either do this in your calculator or by hand. So this first part, take the antiderivative, you're going to get 5x squared over 2 plus 1x. And that's going to be evaluated from 3 to 7. We're looking for f of 7, so I'm going to leave that one. But I know that f of 3 equals 6. Now from here, this is going to be 5 times 7 squared over 2 plus 1 times 7 minus 5 times 3 squared over 2 plus 1 times 3. And then we know that has to equal f of 7 minus, we know f of 3 is 6. So at this point, you can use a calculator since we actually have to find an answer. So here, I'm going to type in this entire left side to my calculator. One second. And you're going to end up getting 104. So I know 104 equals f of 7 minus 6. So that means if we solve this equation here, I just have to add 6 to both sides. So I get 110 equals f of 7. And that would be our answer. Now for 2, you're going to need a calculator because we don't really know how to do this antiderivative. So I'm going to set it up the same though. It's going to be from 3 to 7. But this time we're going to have sine of x squared plus 4 dx. And then we have f of 7 minus f of 3 again. So this is the part you just type into your calculator. And to do that, you're just going to hit menu for 2. That's how you get to like the numerical integral. And when you type that in, make sure it's in radians. You're going to end up getting 0.21898. And that's going to equal f of 7 minus, this time we know f of 3 equals 2. So to solve this one, I add 2 to both sides, and I end up getting 2.21898. Three, we're going to use the same kind of idea, except this time we have a graph, meaning we're going to have to find area under a curve. So this time they tell us that g of negative 7 equals 2, and it's our goal to find all three of these. So for this first one, we're looking for g of negative 2. So when I set this up, I'm going to have negative 7 to negative 2, because you have to put the smaller one on the bottom, of g prime of x, because that's our graph, dx. And then that's going to have to equal g of negative 2 minus g of negative 7. So to find this definite integral from negative 7 to negative 2, I know it's going to be the area of this triangle, because that is from -7 to -2 for your x values. So the area of that triangle is going to be 1/2. The base is 1, 2, 3, 4, 5. And the height is going to be a 1. But since this is below the x-axis, we know it has to be a negative area. So that would equal g of -2 minus, we know g of -7 is 2. So this right here is going to equal -5/2 plus 2. And I'm not even going to simplify it. I'm just going to leave it as that. All right, then I'm going to continue. And I'm going to find g of 2 now. I'm going to set this up the same way, though. So it's going to be from -7 to 2 this time. And then we'll have equals g of 2 minus g of -7. So the area under the curve, we already know the area of this triangle because that's what we found. But if we're going all the way from -7 to +2, I'm going to add in this semicircle. So now I know this area has to be -5/2 plus 2, because that's what this, oh wait, just kidding, not the plus 2. So we have -5/2 is this triangle. And then I need to add the area of this semicircle here. So it's going to be plus, this is half a circle, so 1/2 pi, my radius is 2. So 1/2 pi 2 squared. And then that's going to equal g of 2 minus g of -7. So then here, I'm going to have -5/2. This is going to simplify to 2 pi equals g of 2 minus 2. So my final answer for this one will be -5/2 plus 2 pi plus 2. And then I'm trying to find g of 5. That's this entire area under the curve. So this time we're just going to go ahead and add this last bit, this triangle here. And then notice there's another triangle underneath the x-axis. So we're going to keep the same area that we had. And our integral this time is going to be set up as -7 to +5. So it'll be g of 5 minus g of -7. So we know the first two areas is going to be -5/2. We know half of that circle is 2 pi. Now this triangle above the x-axis, it looks like the base is 2.5. So it's going to be plus 2.5. The height of this triangle is 3 divided by 2. And then this tiny triangle below the x-axis is going to be a negative, so minus. This time the base is 0.5. The height is 1 divided by 2. So you can pretty much leave it like that, but we know it's going to equal g of 5 minus g of -7. And we know g of -7 is going to be 2 like it was before. So our final answer here, we're going to leave it pretty unsimplified, that's fine, is -5/2 plus 2 pi. This one would end up being 7.5 over 2. And 0.5 divided by 2 is minus 0.25. I said I wasn't going to simplify, then I started simplifying, but whatever, plus 2. So all of them should have this plus 2 just because of that g of negative 7. All right, now on to 4. This one is pretty much the same thing. They give us a graph. They want us to find these 3 things. So I'm going to start with f of 2. Notice this time they give us f of 0. So you always have to use the numbers they're giving you, or else you're not going to be able to do it. So I'm going to start with a. This one has to be from 0 to 2, f prime of x dx, since that's our graph this time. And we know that has to equal f of 2 minus f of 0. So my area from 0 to 2 is going to be this quarter circle right here. So that's going to be 1/4 pi r squared. My radius here is 2, so 2 squared. And then that has to equal f of 2 minus, we know f of 0 equals 4 because that's what they give us in the problem. And once again, this area here is below the x-axis, so it has to be a negative. So this right here is actually just going to equal negative pi because the 4's cancel. And then to get rid of this negative 4 on the other side, we're going to add it. So f of 2 is negative pi plus 4, or 4 minus pi. All right, now for b, this time we're going to go from 0 to 6 because the 0 has to be included since we know it. And this one will equal f of 6 minus f of 0. So my area from 0 all the way up to 6, we're going to add this triangle this time. So we already know that negative pi. My base of this triangle is 1, 2, 3, 4. So plus 4 times 4 divided by 2 because of area of a triangle equals f of 6 minus 4. So this is going to come out to negative pi plus 8 plus 4 equals f of 6. And if you simplified that, since it's easy to simplify, you're going to get 12 minus pi. All right, then our last one. Definitely meant to erase that. All right, so the last one here, we're going to have f of negative 2. So in this case, just ignore that. We're going to have it from negative 2 to 0. The smaller one always has to be on the bottom. And this will equal f of 0 minus f of negative 2. So we are ignoring all this area from before. The only area we're finding is this quarter circle. So this is going to be 1/4 pi r squared again. And we know our radius is still 2. And it's below the x-axis, so it has to be a negative. F of 0 minus f of negative 2. So this is going to come out to negative pi like before. We know f of 0 equals 4 minus f of negative 2. So this time, to solve it, we're going to have to move this negative f of negative 2 to the other side. So we get f of negative 2 equals 4. Then I move this pi to the other side and get 4 plus pi. And that would be your answer for C. All right, now we're on to Riemann sums. So 5 wants us to find or estimate the value from 0 to 6. And we're going to do it with left, right, and midpoint. and it wants 3 equal intervals for each of these. So we need to figure out what our intervals are. So here's the first interval, second interval, third interval. And then my change here, it's going to be 2, 2, and 2. So let's start with our left. That's when you start at the left of your table. So our furthest left point is going to be area is approximately -6 times the change in x is 2 plus 8 times 2 plus 30 times 2. And we got those because these are all the left values from our table. So here, here, and here. And you could leave it like this, but if you did need to simplify it, you'd get the area is approximately 64. No units are given here, so we can just leave it as 64. Now for the right, this time we're going to be using our right values. So I'm going to use 80, 30, and 8. So here our area is approximately 80 times 2 plus 30 times 2 plus 8 times 2. And here our area is approximately 236. Now the midpoint, we're always going to use this middle value. So the one that's right in the middle, 0, 18, and 50. And here your area is going to be, so the first one is 0 times 2 plus 18 times 2 plus 50 times 2. So our area is approximately 136. Now the second part of this wants to know how each of these compare to the actual value. So here we're going to draw a picture. We know it's an increasing graph. So I'm going to just draw a little increasing graph for each of these. So if I look at these, the left one, the left part is always on your line. That's the height of your triangle. So notice this one is an underestimate. But if you draw it where the right is, notice it's going over the line. So this one would be an overestimate. And then midpoint somewhere in between. So the middle of your rectangle is on the line. This one's a little harder to draw, but it's somewhere in between. We can't really tell exactly what. All right, on 6, we need to find all these definite integrals. So once again, we have area under a curve. So the first one is just from 0 to 2. I'm going to kind of go quicker on these since we've already done it. But from 0 to 2, we're just finding the area under the curve from 0 to 2. Once again, it's going to be a quarter circle, and the radius is still 2. So here you would have negative pi since it's below the x-axis. For B, we're looking from 2 to 6, so that time it's just going to be this triangle. And I'm pretty sure we've already done this one too. It's just going to be 1/2, 1, 2, 3, 4 times 2. So 1/2, 8 just equals 4. And that one is above the x-axis. That's why it's positive. For C, we went from -4 to 2. So we need this triangle, and we need this entire half circle. So from -4 to 2, this triangle here, base is 2, height is 1. So that means it's just going to be a 1. But since it's below the x-axis, it's going to be -1. Plus 1/2 pi r squared. So 1/2 of 4 is just going to be 2 pi. It's below the x-axis though, so it's minus 2 pi. And that is the answer for C. Now from -4 all the way to 6, that's all of them added together. So this one's just going to be -1. You write this below it. -1 minus 2 pi because that's what we just found. And we're going to add this last triangle that we just found was 4. So plus 4. E is essentially the same thing as D, except this time it has an absolute value. So all that means is we would basically be taking this, and everywhere that it is a negative, we're going to make it a positive. So we're going to take the same exact answer from D, we just have positive numbers instead. So 1 plus 2 pi plus 4. And then for F, we're going to go from -4 to 6, but then we have f of x plus 2. So I'm going to split this up into two different ones. -4 to 6 f of x dx, and then -4 to 6 of 2. Well, we just know what this is. It's going to be -1 minus 2 pi plus 4. But then here, we need to figure out what the area under the curve is for this part. So if you were to sketch a graph of this, we know that it's going from -4 all the way to 6. And we're trying to find the area under the curve for the line 2, which is y equals 2. And that's just a horizontal line. So the area here is area of a rectangle. So our width is going to be 2. The length here is the distance between -4 and 6, which is 10. So 10 times 2 is 20. So you could simplify that if you want to, but you don't have to. And then 7 is more definite integrals. A is pretty much like the one we just did. So they give us that the area from 0 to 5, area under the curve is 4. But then we have this 2 here. This tells us it's going to be a rectangle. So the width of your rectangle is going to be 2. And then the distance from 0 to 5 is going to be your length. So it's going to be 2 times 5. So this represents the rectangle just like we drew above. So this should be 14. Now notice on B, this time it's plus 2, but it's inside the parentheses. All that means is you need to change your limits here. So I'm going to add 2 to both of these. So -2 plus 2 is 0. 3 plus 2 is 5. And that gets rid of that plus 2. Now it's just from 0 to 5 of f of x. And that's exactly what they tell us, so the answer is 4. This one is talking about if f is an even function. So even function means it's the same on both sides, meaning it's symmetrical. So if it's 4 on one side, that means it also has to be 4 on the other side. Which means the area from -5 to 5 just equals 8. But if it's odd, one side is negative, the other side is positive. So if this is a positive 4, that means over here would be a -4. So if it was an odd function from -5 to 5 of f of x, has to be equal to 0 because they cancel each other out. All right, that was the definite integrals review. Now we're going to go on to the one from today, the 2-8 review. All right, so number one is just like one that you would not have a calculator for. This is one you'd be expected to do by hand. So for finding the antiderivative here, you're going to end up with 4x to the third over 3. And that's going to be evaluated from 1 to 2. So this would equal 4 times 2 cubed over 3 minus 4 times 1 cubed over 3. So if we multiply this out, this would become 32 over 3 minus 4 over 3, and you'd end up getting your answer as 28 over 3. Number 2, they tell us a bunch of definite integrals, and we need to figure out from 4 to 8. So I like to draw a picture on these. And we know from 2 to 8, this entire thing has to equal to be negative 10. But then they tell us from 2 to 4, this little area equals 6. So our whole goal here is to find from 4 to 8. Well, we know the entire thing has to be equal to negative 10, so I need to think negative 10 equals 6 plus something. So if I were to solve this, you could also just do this in your head. You would know that negative 16 has to be here because negative 16 plus 6 equals negative 10. All right, 3 is another one you should be able to do in your head. So for 3, the antiderivative is 2x to the 4th over 4 plus 3x. And we're evaluating that from 0 to 2, which would equal 2 times 2 to the 4th over 4. Actually, I'm going to go ahead and simplify that to 1/2 just to make it easier in the end. So this is really going to be 2 to the 4th over 2 plus 3 times 2. And then all of this minus, make sure you put the parentheses here, 0 to the 4th over 2 plus 3 times 0. Since all of this is 0, we can just forget about it and cancel it out. And then this would give us 2 to the 4th power would be 16 over 2 plus 3 times 2 is 6, which gives us 8 plus 6. So the answer would be 14. All right, number 4 wants us to find the area under the curve from negative 2 to 4. We've done this a million times so far. So it's going to be this area from negative 2, this area here, and then the area of this triangle from 3 to 4. So we'll start off with this area of this quarter circle. So 1/4 pi, radius is 2, so 2 squared. That one is positive. Then minus, this time the base is 3, the height is 2, divided by 2, plus this base is 1, the height is 2, divided by 2. So this will come out to pi. This comes out to negative 6 over 2, which is negative 3. And this just comes out to plus 1. So we're going to end up with pi minus 2, which is C. Okay, D, they give us a bunch of integrals, and we need to figure out what 0 to 2 is. So if you look at these, we know we have the entire thing from 0 to 5. And that has to equal the area from 2 to 5 plus the area from 0 to 2. So if I know the area from 0 to 5 is 2, from 2 to 5 is 6, I'm just trying to find the area under the curve from 0 to 2. So if I subtract 4 here, you get this is actually equal to negative 4. But that's not what the question is asking. It wants it from 2 to 0, which is equivalent to the negative of 0 to 2. So our answer here is actually negative 4, which would come out to be positive 4. Number 6 is talking about Mr. Kaji's gold chain. And this one wants to know how much was added during the first 4 minutes. So this does not mean you can just plug in a 4. This means we have to figure out what the area would be from 0 to 4. So I set up a definite integral from 0 to 4. And then we use the function that they give us for the rate, which is 3t squared plus 2t dt. And really at this point, you can just put that in your calculator. You could do it by hand, but either way, you would end up getting 80 gallons. So that is how much is added in the first 4 minutes. You can't just substitute this 4 in because that would be how much is added at 4 minutes, not the entire time. And B wants the total amount of liquid gold after 4 minutes. So that's going to be the 80 gallons that were added plus this 20 gallons that were already there. So the total amount would be 100 gallons. And then for the Riemann sums, A tells us it wants a left, B tells us it wants a right, and then notice this is really just modeling how much the temperature is dropping. So for A, we know we're going to use a left, so we're going to need the change here. Change is 3, 2, then 3. So our left would be approximately 5.5 times 3 plus 2.7 times 2 plus 1.6 times 3. And that is approximately 26.7 degrees Fahrenheit. This time you do have to get an actual answer because it wants the total temperature after 8 minutes. And then up here it tells us it starts at 113, so it'll be 113 degrees minus 26.7 degrees. So after 8 minutes, our estimation using Riemann sums is approximately 86.3 degrees Fahrenheit. And then for B, it's going to be pretty much the same thing, except we're going to use right. So here we're going to start with the 0.8, and it's going to be times 3 plus 1.6 times 2 plus 2.7 times 3, and that's approximately 13.7. So if you subtract that from 113, you're going to get 99.3 degrees Fahrenheit, approximately. And that should be the entire review.